Hey, this is OXDF, and today we're doing Advent of Code 2023, Day 15, Lens Library. For part one, we're going to implement a simple hash value. And a hash, and this is like a super simple hash value. We're reducing it to a single byte. So it's not a very good hash, but fine. And basically all we need to do is start with 0, add the ordinal value of the first character, multiply by 17, take it mod 256, and then repeat. Add the value of the next character, multiply by 17, mod 256, etc. They give us an example here for the word hash. We also have this example string. So what our input's going to look like is more like this. So hash is going to be 52. We'll know that. This string, we're going to loop over, like each of these strings is comma separated. And so we're going to get a bunch of hashes for those, and we're going to sum them up. Not seems surprisingly too easy. Which famous last words? We'll see what way I find to screw it up. Let's see. Before we do that, we can do example.text. So my Genday script here, there'll be a link to the GitHub repo in the description. But basically, it is pulling the input for me here, as well as making me a stub to work off of. Input, much longer than the example. Single line. It's specifically said in the instructions to ignore new lines, so we're going to chomp that off. And nothing difficult there. Let's go ahead and dive in. We will create our function. Def. I don't want to call it hash. Oh, we can call it. I think hash is a keyword already, isn't it? Let's try it. Let's see. We explore. Hash test. Yes, it is. So we don't want to call it hash. We'll call it like def badhash on s, which is a string, and returns an int. And for badhash, all we're going to do is say h equals 0 for c in s, h plus equals ord of c, h times equals 17, h mod equals, I'm pretty sure we can do that, 256, turn h. I believe that is that simple. So we could do something like badhash of hash, make sure it's 52, just to sort of we're in the right spot here. Python day 15, it doesn't really matter what we give it here because we're not using it. 52, that's what I said, right? Hash is 52, so we have our hash. Next thing we need to do is process this input, and all we need to do is strip the whole thing. Let's see, so we don't need to read lines. We're gonna read dot strip like that to get rid of things. We'll call this line. Actually, let's do this. Let's just do it right here. Words dot split on comma. And so now if we just do words and run this again, we get our words. And so now we just need to do word for word in words like that. And what are we going to do for the words? We're going to badhash them. And then we're going to sum that. And we're going to get 1320 matches there. So we just need to input.text, we get an answer. And we got an answer. All right, let's give it a look. I'll be back in a moment. Okay, this is incredibly complicated, but I think I've got it. I think I understand. We're gonna have a series of boxes, 256 boxes, 0 to 255. And then we are going to, these are instructions. And so where's my, okay, I guess we'll go here. So when I get Rn equals 1, what I need to know is, I believe the hash of Rn is 0. We can verify that. Let's make sure. Let's see, part 2 equals badhash Rn, like that. It is 0. Sweet. Okay. So because the hash of Rn is 0, we're going to put it in box 1. We're going to put the lens Rn into box 0. That's the hash. And it's the first one in box 1, and it's got a value of 1. The next thing, there's two operations. The equal sign means set it. The minus sign means take it away. Well, the CM minus doesn't make any sense because CM's not there, so we just ignore it. QP equals 3. The hash of QP QP, let's run this again, is 1. Okay, so that means box 1 gets QP and the value is 3. CM is going to hash to 0. So now we have a second lens in box 0, and it's got a length of 2. QP minus, now we remove QP from here entirely. PC equals 4. PC hashes to 3. We put it in box 3 with a 4. OT equals 9. OT hashes to 3, so we go to box 3. It's not, and the order here matters too, so we're going to put that there. AB equals 5. It's another one in box 3. PC minus, now we're going to remove this one, so these kind of slide up. And let's see, PC equals 6, so we're now going to add PC back to the end. OT equals 7. Now we don't add it to the end here because OT is already in the box. We just changed the value. So at the end, we're going to multiply together 1 plus the box number, so 1 to 256 basically instead of 0 to 255 of box number, times the slot number. So this will be 1, 2, also 1 numbered, 1 indexed, times the focal length. And that'll be the power of that lens. And so like Rn, we get all these powers and then we sum them together. We sum over all our lenses and sum them up. I got something in my eye. This is very complicated, but I don't think it's gonna be that hard. I think the important thing to keep track of is we need to know the order in each box. So like in this case, we need to know if PC, OT, AB. And we need a mapping of like PC is currently set to 4. But we don't have to do that together because PC is, the fact that PC is in box 3 is not interesting. PC will always be in box 3. It's just the order within box 3 that matters. And so we just need to know. So I think we can keep those in 2 structures. Let's give it a go. Okay, so let's see. We've got our part 1. Part 2. We're gonna have to loop over words here. Let's see. For word in word, or I guess we'll call it instruction maybe. Inst in words. Okay, in words, that's fine. Now we're going to have, that'll give us Rn equals 1. We're going to say, we're going to split on equals. If we split on equals and there is no equals, so if we have Rn equals 1 like this, dot split on equals, that's going to return us 2 things, right? If we split on equals, well, maybe we should just do a check. Let's do a check. So we'll say if equals in Rn, in inst, label, comma, value equals inst.split on that. Then what are we gonna do? Once we do that, we better start up here. We'll say boxes, and what are we gonna need? We're gonna need 256 boxes, and each of those is gonna be an array. We're gonna say like this for underscore in range to 256. I think that'll work. That'll give us an empty array for each of 256 empty arrays. So now we come down here and we say label equals that value. What's that? Box sub. Interesting. Our hash values were our numbers. Okay, yeah, that's right. Okay, so we'll say box sub bad hash of label. That needs to be parentheses, not there. Box sub bad hash of label dot pen. Let's see. If label in box, if it's already there, then we don't need to change label not in boxes bad hash label. If it's not there, then we need to boxes bad hash label dot append label. Then we also we're going to need to keep track of focal length map equals like this. And so then we can say, actually, let's do, yeah, okay, that's fine. So we'll do that, and we'll say focal length map of label equals int value. Okay, so now if it's an equal sign, we are going to check it. We're going to get the label and the value. If the label is already in the box, then we will, if it's not in the box, we're going to append it to the end. If it's it, and we're, no matter what, we're going to update the focal value. Okay. Elif inst dot ends with this, and I could just do else, obviously, but what I'm going to do now is I'm going to say else assert false. So we throw an error because I want to just be aware that if I hit something else, I want to know it, right? So now we come here and we can say if it ends with a thing. So what we need to do, we need to remove it from the boxes. So we'll say if, so we can do label equals int dot strip, like that. If label in boxes the bed hash label. If the label's in the box, we're going to do boxes. This is embarrassing. How do I remove a thing from a label? So if we have x equals 1, 2, 3, that x dot del x dot remove, is that a thing? 2, 3. So if x is equal to, I want to pick different numbers just so I make sure I'm not getting like an index or something here. So 3, I hope. Oh, there is no 3, perfect. Okay, so I am removing a value. If I remove 8, now x has that, perfect. So I want to boxes bad hash label. I guess I could just hash this at the beginning. That's really what I should do. Nah, okay, it's fine. It's so fast, it doesn't matter. Dot remove label. Sweet. So there we go. So we've removed it from the thing, and if it's not there, we don't do anything. And then do we need to do anything with the focal length? I guess we could remove the value, but I actually don't think it matters because if it's not in the box, we're gonna loop over the boxes to calculate the score. So I don't think it actually matters. That might come back to bite us, but let's try that for now. Okay, so that should give us a list of. In fact, let's just let's do this. Let's do Python -i day 15 example input, and we should be able to do boxes and see what we got. We have, oh, this looks good. We have at the end here we have RN and then CM, and we have OT, AB, PC. So that looks good. And if we do focal length map, we have RN is 1, QP is 3, it doesn't matter. CM is 2, PC is 6, OT is 7, AB is 5. So I think we're good there. So now we just need to calculate the score. And that, we need to review. We need to loop over, let's see, where are we? We need to loop over each lens. We'll go over each box for each lens, and we'll get the box number times the slot number times the focal length. So that shouldn't be too hard. Okay, so we're going to say part 2 equals 0 for box in boxes, for lens in box, and we saw that's going to give us like just a RN. So lens will be RN, for example. And we need to enumerate this. Enumerate, and we're going to actually enumerate comma 1 so that we get one value. So we'll say BN, and we'll do enumerate, and again, oops, box comma 1, and this will be LN. So now we're going to say part 2 plus equals BN times LN times focal length map of L lens. Let's give that a go. 145. 145. Oops, I didn't want the -i. Got an answer. Sweet. This one, almost all the challenge was in the complexity of the part 2. Part 1 was a piece of cake. Like, I feel like that could have been up day 3, right? But the complexity in the part 2 is just like understanding the map. I think the key thing we did was having this, realizing that we could keep, not trying to keep some structure in the boxes that also stored the value. It wouldn't be that hard, honestly. We could, let's see, instead of appending label, we could append like label comma, like a tuple that was label, and well, so we could create a class that was like a lens, right? We could create and then we could have a lens, have a label, have a value, a focal length, and a label, and then put the lens in there. It just makes updating a little harder because now if we want to update, we have to actually go in, find the right lens, and modify it. It wouldn't be that hard, honestly. So I'm not really sure what's supposed to be hard about this, other than understanding it. But cool. I'm gonna call it here. Thanks for hanging out with me today, and I'll be back tomorrow.